In this video, we are going to talk about Cramer's rule. We are going to see the derivation of this Cramer's rule and how it works. We apply in equation as well. So first of all, check what we are going to get here. Let's multiply the first equation by B2 and the second equation by B1. Then we get a1b2x plus b1b2y equal to b2c1, and from here we get a2b1x plus b1b2y equal to c2b1. Okay, now if we subtract, then we get a1b2 x minus a2b1 x, and this thing gets cancelled. Here I get b1, sorry, this one I get b2c1 minus b1c2. Okay, from here if I take x common, if I get x common, then I get a1b2 minus a2b1, and here I get b2c1 minus b1c2, or I get x equal to, if I write this thing as c1b2 minus c2b1, then it's not going to change its meaning. Upon I have a1b2 minus a2b1. Okay, so now I'm going to multiply the given equation, this given equation, by a1, a2. Let's check what happens. Now again I am going to multiply the first equation by a2 and the second equation by a1. So I get a1 a2x plus a2b1y equal to a2c1, and here I get a1 a2x plus a1b2y equal to a1c2. In the next I get, if I subtract this thing again, then I'm going to get a1 a2x minus a1 a2x plus a2b1y minus a1 b2y equal to a2c1 minus a1c2. These two terms are like terms and equal, so we can cancel it out. Now I'm left with a2b1y minus a1b2y equal to a2c1 minus a1c2. If I take y common from here, then I get a1b2 minus, sorry, I get a2b1 minus a1b2 equal to a2c1 minus a1c2. So I get y equal to a2c1 minus a1c2 upon a2b1 minus a1b2. Okay, so from here I can write this thing as, if I take minus 1 common, then I can write a1c2 minus a2 C1. Similarly, if I take minus 1 common from here, then I can write A1 B2 minus A2 B1. So this minus 1 and minus 1 got cancelled, and finally I got y equal to A1 C2 minus A2 C1 by A1 B2 minus A2 B1. Okay. So now let's check what are these terms that we got, y equal to and x equal to. Here we can see the same equation can be written in the form of matrix like this. Okay. So this is matrix A, X and matrix B. Okay. From here I get the determinant of this matrix as A1 B2 minus A2 B1. Okay, and if I replace this term, these coefficients of x, right, coefficients of x, if I replace this term and bring here, so that means this C1 C2 comes here, then I get the determinant of x, which will be C1 B2. If I bring this C1 C2 here, C1 here, C2 here, then I get C1 B2, C1 B2 minus C2 B1, C2 B1. Okay. Similarly, if I replace the coefficients of y from here and bring C1 C2 here, then I get the determinant of y, which will be A1 C2 minus A2 C1, A2 C1. Okay. So remember the term that A1 B2 minus A2 B1 is the determinant of matrix, which will be denoted by the letter D, and C1 B2 minus C2 B1 is the determinant of x, which will be denoted as dx, and A1 C2 minus A2 C1 is the determinant of y, which will be denoted as dy. Okay. So now let's check our solution of the previous equation. Now here we have got C1 B2 minus C2 B1, A1 B2 minus A2 B1. Okay. So now let's check what were these two things. Okay. You can see that C1 B2 minus C2 B1 is dx. So we are going to write here, this is equal to dx upon, and what is this thing? Let's check. This thing is A1 B2 minus A2 B1, which is d. So we write here d. Okay. So now let's check what is the solution of y. The solution of our y is A1 C2 minus A2 C1 upon A1 B2 minus A2 B1. Friends, we know that A1 B2 minus A2 B1 is the determinant of matrix, which is denoted by D. And what is this? Let's check. And this term is the determinant of y, which is denoted as dy. So this thing is dy. At last we got that x is equal to dx by d and y is equal to dy by d. Now let's take one example to solve using Cramer's rule. Now we have the question to solve using Cramer's rule. So this equation number 2, let's rewrite this equation because these are not in the standard form. So I'm going to write the first equation as 5 by, let's first write the coefficients of x. So let me write here 4 by x plus 5 by y equal to 58, and this second equation can be written as 7 by x plus 3 by y equal to 67. Okay. Now this equation can be written in the matrix form as shown. Now we write this equation as coefficients of x, coefficients of y, and the constant terms. Okay, constant terms. So coefficients of x, sorry, here the variables are 1 by x and 1 by y, so we are going to write as coefficient of 1 by x, 1 by y. If there we had like this for x plus 5y, then we write coefficients of x and coefficients of y. But here we are given 1 upon x, so the coefficients of 1 upon x and 1 upon y. Then I have 4 here and 7 here and 5 here, 3 here. So my constant terms are 58 and 67. Dear friends, coefficients of x are a1, this is a1, this is a2, this is b1, b2, c1, c2. Okay, for your convenience I have written here, but it is not required to write in the solution. Now let's calculate what is d. d is a1 b2 minus a2 b1. So a1 is 4 into b2 is 3 minus a2 is 7 into b1 is 5. So I have 4, 3 is 12 minus 35. Then I'm going to get it as minus 23. Let's calculate what is dx. So dx is c1 b2 minus c2 b1, which is 58 into 3. 58 into 3 minus 67 into 5. Okay, so this is 174 minus this one is 335, and if we subtract we get minus 161. Now let's calculate what is dy. dy is equal to, we have a1 c2 minus a2 c1. So a1 is 4 and c2 is 67 minus a2 is 7 and c1 is 58. Now let's calculate. This one is 268 minus this one is 406. 268 minus 406. I have minus 138. Now, friends, using Cramer's rule, we have Cramer's rule, x is equal to dx by d. So my dx is minus 161 upon d is 23. So it is going to be, sir, this is minus 23. It is going to be 7. Okay, and y is equal to dy by d. And the dy is minus 138 by, and this one minus 23. It's equal to 6. Okay. So if x is 7 and y is 6. Sorry friends, we had the variables as 1 by x and 1 by y, so our solution also comes as 1 by x and 1 by y. Okay, 1 by x and 1 by y. So from here we can say if 1 by x is equal to 7, this implies as x equal to 1 by 7, and if 1 by y is equal to 6, this implies y equal to 1 by 6. So our solution is x comma y equal to 1 by 7 comma 1 by 6. This is our answer. If you like my video, don't forget to subscribe my channel and share the video. Thank you so much.